Thanks a lot for joining me today. My name is Ahmed, a technology platform manager in Telstra Health. I look after centralized technology platform, including API management. And this was my journey also in the last couple of roles. One of them is in AGL Energy, where I was looking after the API platform team. So we do a lot in the API space, API programs. And a lot of what I do in the day-to-day is related to security. So happy to share some of that kind of practical guidance that I have gained through in my experience. I'm sure you all know OWASP Top 10. Like there's no good security talk unless it actually brings that slide somehow. So this would be the base of my talk. Basically, what we are trying to do is to start from those common, most critical security risks that is published by security experts, and trying to see how an API platform, how an API gateway can help mitigate some of these risks. So let's start with a simple question. Could be, what is the difference between API management and API gateway? So the answer is simple. API management is a product or a system that has two main components. API gateway, and this is actually towards the services. It's kind of linking that mobile web application to the service at the top. And an API developer portal. So the developer portal is more towards people, not services. What does that mean? While the API gateway has features like representation, caching, and security, it's protecting your APIs and services. The developer portal is making your APIs available, discoverable, securely to your developers. Those developers could be in your organization, it could be in a partner organization, or it could be external developers just outside of your organization or your partner organization as well, like in the community. So it's essential to make sure your API strategy is actually serving those three actors. And my recommendation is always to use the same system, the same program for both internal and external and partner organizations. It's one of these things that it's really hard if you have 3 different API programs in your organization, right? So the first thing I want to talk about is authorization, right? Even if you haven't actually written any security code before, or even if you haven't actually worked on Azure API management before, I want you to look at this XML declarative syntax, and after a while, raise your hand if you can understand what it's doing. Please. Right? Couple, all right, 3, 4, all right, 6, all right. Okay, people are still coming, 7, 8, all right. That's really good. So like, even though we have people in the room that might not have used that technology before, they can actually understand that declarative code. What that code is doing is simply protecting an API by making sure the request is actually authorized before it reaches the API backend service, right? How that is important because in order to succeed in an API program, visibility is really important. So to be able to have a single source of truth where all of your API architects and developers and security team, they don't have to go through tons of code to find out how your API is secured, is really important. So it's really important to have your first line of defense, right? Declarative and easily understood by all of your organizations. So I work in organizations where there's .NET, there's Java, there's Python, there's all sorts of technologies. but the information about security, how APIs are secured, is essential. So when you have this visibility, it actually helps a lot. So make sure to use your API gateway to be the first line of defense that is related to authorizations. This can be OAuth, I hope, OAuth 2, but you also have so many ways to protect your APIs, and API gateways tend to have that capability. So the other benefit that this gives you is decoupling between your front-end authorization and your back-end authorization. So often you will find in your journey that you have very weak legacy systems that, let's say, they have basic authentication or API keys, and you don't want to bubble that to the client because of all the security issues. You want to hide that in your network perimeter and offer a facade on top of that because you can't touch it. We have always seen that in enterprises. So that actually gave you that capability as well. Great, simple architecture. I promise this would be the only kind of architecture diagram that you would see today. Maybe one of the things here is the, let me just get the pointer. Right, so you see a couple of actors here, the public actor, which is coming through the internet, and a private actor, which is, this is your staff members, these are your employees going through a VPN, going into your network. It's important for your API strategy to serve both at the same time. And the advice here is to always deploy your API gateway in a private network, right? That's a private network on Azure. So you have your WAF first. That's your OWASP kind of WAF appliance. And then you have your API gateway that is executing API policies. And then you have your other private infrastructure that either in the VNet or in a peered VNet using a hub and spoke model, which is pretty common architecture. And then this can also go outside of the private network if we want to. So my advice is when you deploy an API gateway, make sure it's deployed privately, because that would save you a lot of pain after that if you started publicly and now you have the requirement to make it private. The other advice is make sure your backend system is not just putting something behind an API gateway. You have to block access of everything else except the API gateway. So by making sure that that's in a private network, that's one step. But there are different ways you can also make sure that requests are coming from the API gateway. So based on the technology that you are using. Right, let's move to, so we're still in the broken access control. That's number one in the web application OWASP. These things would actually mitigate that risk. One of the things that is always pain to manage is CORS. If you have ever worked on a microservice system, you have so many Lambdas and Azure functions, and you have a thick client, and you don't actually want to have that logic in hundreds of ways in your application. So centralize that into the API gateway and decouple it from handling any browser-related issues. I don't care if what calls my backend is an application in the browser, or if it's an unattended cron job or whatever. Really, it's not something that me interested in writing code in the business API need to worry about. So another thing is, usually when you have applications, you have a lot less applications than what you have APIs. And that means you can actually abstract that course in a product, which is a collection of APIs, and apply it to across all of your APIs instead of individually having to secure each API. And we established the network security. So this is zero trust. We have to establish that the backend service is making sure that the requests are coming from your gateway, right? Let's move to cryptographic failures. It's really interesting subject. There's lots of versions out there, TLS versions, that are insecure, right? You want to make sure your API gateway is configured correctly to disable all of the weak ciphers and insecure TLS versions, right? So API gateway would help a lot in that. Your kind of day-to-day backend services written in C# or .NET might not have the same capability in the same strength, right? So, but the thing that you need to do as well is to understand where your front-end TLS handshake happens, right? So this is from the gateway, from the front. You need to know, is that an edge server? Is that an Azure application gateway? Is that the API gateway? You might have different proxies. So you need to ask yourselves, where is the client TLS handshaking happen? And make sure that that is secure, right? Don't secure along the line and forget the front, right? But relevant to that, ask your security teams, are we doing TLS termination? Are we doing termination, or are we doing end-to-end encryption? So TLS termination is something related to the traffic is encrypted up to a certain point and then decrypted. And then just fly through unencrypted. So it might be good for performance reasons, right? But might not be good for governance or for more highly restricted environments. So you have to understand which model you do, which model your application is following, and take appropriate decisions based on that. Also still in cryptographic failures, and also like I'm really a fan of policy as a code and self-service. So make sure your API gateway is configured to have policies that instead of having lengthy review processes where humans get involved, put your policy, lock it in. That's an example of an Azure policy that is saying we cannot do HTTP because it's unencrypted when we talk from the gateway to a backend service, and we cannot do WS, right? These are unencrypted, so it's not allowed. So anyone from any team wants to provision something like that, it's not, they're gonna get an error. Now they don't have to go to someone to review the code anymore because you're confident that you covered this in a policy. Another great example is adding security headers and also removing informative headers. That's a big, if you have ever seen a penetration testing report, oh, yeah, you have a server header coming up. It's high, right? Don't wait until you see that, right? Just go to your API gateway. In the global policy, list all of OWASP informative headers in your global policy as remove, right? You do it once, you don't do it per API, and you just job done, right? Include all of the security headers that is related to APIs. Follow OWASP recommendation. There's a page that has a table of, I don't know, 20 or 30 security headers. You do it once, and then you forget about it because it's in the API gateway global policy, and we already established trust. So that would work pretty well, and you would never see this in a penetration testing report again. Now, a great example of API gateways and how people can work together, right? You know, you have seen a lot of Swagger UI, right? If you work with APIs, you have Postman collections, you have Swagger UI, you have, I don't know, Confluence document, you have APIs shared in email, you have partners who you might have sent API secrets before, right? This all need to change, right? This organization discovered in one of the projects like 13,000 Swagger APIs living on the internet. That means public API definitions, which means it's helping attackers understand how your API work, right? API gateway help you, API management help you not to do that with the developer portal component, which is allowing for governance of acquiring information on your APIs. So those people need to sign in, need to log in with their organization account to access this valuable information. And even if they are partners, you would enable them to sign in with their organization sign-in accounts and give them access to your own organization API information as well. So the same technique works with the three actors that I was talking about. So that helps mitigate number 5, security misconfiguration. Another example of security misconfigurations is you see in the news thousands of API keys leaking, right? So always really interesting. How do we make sure that a single page app or a mobile application wants to consume an API that's using API key or client credential flow without having to store the secret in the app, right? It's really hard, right? But API Gateway would help you solve that problem. There's the pattern here that I'm describing. It's called API Gateway as a secret store, and an alternate to that pattern is API Gateway as an outbound proxy. So you would have lots of flexibility here to secure and identify your application, right? And then you abstract how you access third-party APIs using the API Gateway. So your API Gateway can act as a secret store. Basically, what's the secret to Twilio? They give you the secret, and then your client can actually now go and talk to Twilio. A different, maybe easier way is also to use it as a proxy, which means your API Gateway is not just standing as a proxy to your own APIs. Something that proved to be really successful for me in the past is your API Gateway can also proxy to third-party APIs. What does that mean is you might have Azure Managed Identity here, for example, right? Doesn't have to be API key, but that's all what the client need to understand. And the same identity could be providing access to both these three APIs. And API Gateway have the logic that, get the secret for HubSpot, get the secret for Twitter, get the secret for Twilio, all safely stored, encrypted, hidden from the clients. Really powerful. An example of that is a new feature that was developed in Azure API Management, and that's actually doing more fancy stuff that previously we had to write this stuff in the past. For example, refresh the token if it's expired, right? So it's really, really good feature. It would help you in these situations, like if you have a single page app or maybe an unattended scenario that you don't actually have a person behind that to go through the consent flow. So you establish that at the beginning when you create the connection, and from now on, it's the API Gateway responsibility to keep your token alive and use it when it talks to the backend API. Great. Now we are going into more of the API-related risks here. This one is lack of resources and rate limiting. So basically, how do we prevent overloading our services, and how can the API Gateway help with that? So my advice is always set max request size and a max file upload limit. Also, if you have done penetration testing reports, you will always find, we can just hit you without a limit, right? If you are behind an API Gateway, that makes your life easier because you can just establish that as a one setting, right? Not per API. That's your baseline. And you can say, my max request body size is this, and my max file upload size is that. All of APIs would be protected by that. My advice as well is to set a max request timeout globally. Timeout is important with the size because there are some attackers that will send you 1 kilobyte, but they are sending it byte by byte over a long period of time, causing connection draining in your backend system. So you have to be aware of that as well, and you have to set request timeout as well. As I said, sensitive services can have more restrict limits, but that's your baseline in the gateway. Rate limits, you can see this example started to show some code here. Really simple way to say, I only want to get 3 calls every 15 seconds. based on whatever subscription ID of the incoming request is. So I believe that every API must have a rate limit, right? There's no way someone might say, well, there's a case where an API does not need to define a rate limit. What does that mean? Because there's no infinite resources, right? Everything has a limit. So you might say my API can receive 1 billion requests per second, right? But that's the limit. So it's a large limit, but it's a limit. So you have to define a rate limit for every API, and you have to understand your limits, right? And always good to define a global rate limit as well. So like you obviously need to get this from a local information, but it's good to have a baseline as well at the global level. As you can see, that's another way of using your API gateway, using declarative policies in the outbound section here of your request pipeline. I'm just saying store this request in the cache for 20 seconds. That's how you use it. It's as simple as that. Store this request for 20 seconds, right? And in the inbound, right, if another request come in within these 20 seconds, it will just do a cache lookup, right? And you have full control here. Where do you want this to vary by or expire? So each time here I get a different authorization header, right? Because we're using OAuth2, I want this to be a new response, right? Because it's local to that particular user in this case, for example. So that obviously help ease out the load of your backend services because your requests are not hitting your backend services at all. So we moved from rate limiting resources to excessive data exposure. Now, one of the great features in any API gateway, I show you the developer portal and API definitions. So API gateway understand how your API work. So it understands the schema of all your requests and responses, right? So what you can do is you can say something like this, simple like that, allow additional properties equals false in your validation, right? That means if you are within a request and someone try to add new properties to the payload that you have designed, it's going to be rejected 401 without bothering your engineering teams or your developers to actually code that in their backend services, right? It also works both ways. So this example is response schema. So information exposure always happens from responses. So you build an API, you have let's say a database like this graph, and then someone changed the code to return payload from database directly without checking what to return and what not. And that comes with excessive information, sensitive information that we don't want to return. So the idea here is to focus on the API contract. So we are doing contract first API development, or even if you're doing code first API development, someone reviewed the API contract, upload it to your API gateway or link it to your API gateway, and the contract have to change first before an additional property is added into your response payload. Yep. So always do that kind of validation to make sure that you kind of not left out with more information that you need to. The last thing I want to talk about is injection, and always have a web application firewall in the pass. So in this design, this is acting as a web application firewall. So it will have your OWASP protection against stuff like SQL injection properties and all of that stuff, and make sure that your system is not accessible beyond the gateway. That's an example of the WAF rules. You will be familiar with the OWASP rules. All of them make sure that they are enabled and they are blocked, and make sure that there's enough sufficient monitoring related to that. In addition to that, you might have the cloud vendor like this is giving me also protection from malicious bots that we are talking about. So make sure that that's enabled, and that will block bad bots trying to hit your systems based on that kind of malicious IP. That's it, guys. Thanks a lot for having me, and I'm now ready to receive any of your questions. Thank you. Thanks. Anyone have a question? Yep, Rajan.
In the first slide, you were talking about the validation, JWT token.
Yes.
Will there be any scenario where we need to validate at the product level rather than doing at the API level?
Okay, you mean in the backend service? Obviously, yes. So what? Okay, so the question is, where do we validate? Do we validate in the API gateway and then walk away, and then the API, the backend service just assumes that validation has been done? Or do we revalidate, let's say if we're talking about customer consent, right? Do we revalidate consent in the backend service or not? So, yeah, okay. Okay.
I agree that the best practice is validating at the top level,
yeah.
at the APM level.
Yep.
But what I was saying is that will there be a scenario wherein you need a different mechanism of validation at a API level?
Yeah, exactly. So, yep. So yes. For example, I'll give you an interesting one. So the number one vulnerability or risk in the API top 10 is object level authorization. So you cannot use the API gateway to protect you against object level authorization risks, because it needs the awareness of the object. You need to understand the scope, your IDs, you have your local DB, and if someone passed a different ID with a different role, right? The API gateway doesn't have that information, right? So the API gateway would validate that the token has been signed, might validate the issuer, the audience, might validate the claims, but it would not know if that user have access to that entity or not, right? So you still need to revalidate that in the API somehow. A good example in that is token exchange flow. So token exchange flow, for example, the API gateway would receive a token as a middleman, but also pass the token to the backend service. And the backend service now would understand that the token is coming from the API gateway, but I still can do further checks and do DB lookups and even validate the signature of the token again, the code. So it's really up to the security policies, but I would advise that no, it's not just the API gateway. We're not trying to build the centralized authorization management. The local checks still has to be there. The API gateway is just your first line of defense. Yeah. Yep. Thank you.
With encryption, what do you recommend? Do you recommend end-to-end or encrypting?
Well, great question. I do recommend end-to-end encryption, right? It's not until you really have a strong performance. If you want to save like billions of requests per second and your infrastructure is struggling with the end-to-end, right? First, I would say minimize number of proxies if you can, right? For example, if you can use Azure Front Door as an edge server and application gateway at the same time, then use it. So you minimize number of proxies. But if that didn't work, then don't go for TLS termination. But end-to-end encryption is my advice. Yep.
So in one of your slides for the excessive data,
Yep.
not sending the excessive data. So how does the gateway will know like this is the required data? Because if you are going to stop at the gateway level,
Yep.
Only the gateway, the backend service will know what data
Yep.
it needs and what it
No, because the backend service has to publish its API definition somehow. So the team that's building the API has to say, these are my API definitions. So from that, the API gateway knows exactly the schema of your payloads, whether it's request or response. And it can use that for validation and making sure there's no additional properties coming in or out. Yeah. All right. Thanks a lot. Thank you. Thanks for having me.